Guys, in today's video we'll learn about the topic which is called BET surface area analysis. So the word BET basically means Brunauer Emmett Taylor surface area analysis. So this is also called the multi-point measurement of an analyte specific surface area through gas adsorption analysis, where an inert gas like nitrogen is continuously flowed over a solid sample, or you can say the solid sample is suspended in a defined gaseous volume. Now the BET basically is measured in terms of meter square per gram, okay, and it is commonly used to evaluate the gas adsorption data, okay, and the BET is also used to explain the physical adsorption of a gas molecule on a solid surface, and it is also an important technique for the measurement of the specific area of the materials. Now this BET is basically the observation which refers to, you can say, the physical adsorption or physisorption. We can say this physical or phys, and this theory applies to system of multi-layer adsorption that utilizes a probing gas called adsorbate that does not react chemically with the adsorbed material upon which the gas attaches to quantify the specific surface area, or you can say surface area, okay. Now let us go ahead with the background. So in the past few years, the nanotechnology, okay, the research has expanded out of the chemistry department, and it is basically applied into a lot of fields like energy, medicine, aerospace, and even computing and information technology, and a bulk of materials, okay, because the materials is used everywhere. So this is significant, okay. And when the particles are only 100 to 100 nanometer across the different properties, okay, so there is a huge requirement of the use of BET. For example, noted here is commercial grade zinc oxide has a surface area range from 2.5 to 12 meter square per gram, okay, while the nanoparticle zinc oxide can have surface area as high as 54 meter square, and we also see the commercial graphene or activated carbon, which surface area can go even more than 1000 or more than 500. Now the pore, basically the pore width, the pore volume can make a much difference in case of BET, okay. So the pore width and the pore volume are basically the total volume. Basically the pore volume is the total volume of very small openings in a bed of adsorbent particles. The larger the pore volume is believed to allow a rapid access, okay, of the oil to a small clay particles, okay, and therefore any efficient, in terms of the crude oil bleaching will happen, okay. Now the pore diameter is defined as a diameter of a sphere whose volume equals the pore volume. Now the pore volume is basically the net volume into porosity, and pore volume is basically measured in terms of centimeter cube per gram, and porosity is defined as the ratio of volume of voids to the total volume of the soil, okay. Now basically there are 5 types of isotherm which is basically used in BET analysis. So first of all, the type 1 is a pseudo-laminar isotherm because it depicts monolayer adsorption and is obtained where P by P naught is less than 1 and C is a constant which is applied in BET is greater than 1 in the equation, where P by P naught is the partial pressure value and C is the BET constant, which is related to the adsorption energy of the first molar layer and varies from solid to solid. The characterization of the microporous material, okay. So let us go, what does the word microporous, mesoporous mean? Actually I have written, okay, Okay, so I mean so you see that, I mean, as per IUPAC, it has three categories of pore sizes. So one is microporous, mesoporous. So microporous size will be less than 2 nanometers, and the mesoporous sizes will lie from 2 to 50 nanometers, and macropores size will be greater than 50 nanometers. Okay, so we are talking about type 1 isotherm. So here you can see the pic which is taken from the scientist. So you can see the pressure is the volume adsorbed versus pressure. So this is the point of pressure of saturation. Okay, now the type 2 isotherm, which is very different than the Langmuir model. The flatter the region in the middle represents the formation of a monolayer. Type 2 isotherm is obtained when C is greater than 1 okay, in the BET equation. This is the most common isotherm obtained when using BET technique. At very low pressure, the micropores will filled with the nitrogen gas. At knee, the monolayer formation is beginning, and multilayer formation occurs at medium pressure. So at higher pressure, the capillary condensation occurs. So this is the pic. Okay, you can see here. Which is a bit different from the type 1 isotherm. And isotherm basically plots the volume of the gas adsorbed into the surface of the sample as pressure increases, which is adapted from this scientist. Now in the type 3 isotherm, which is obtained when C is less than 1, so compared to type 1, type 2, where C was greater than 1, and shows the formation of a multilayer, and type 1, type 2 where monolayer, because there is no asymptote in the curve, so no monolayer is formed, and PET is not applicable here at all. So this is the pic. And in case of type 4, which is applicable to PET, so when capillary condensation occurs, the gases condense in the tiny capillary pores of the solid at the pressure below the saturation pressure of the gas. At lower pressure region, it shows the formation of a monolayer followed by both the layers will form monolayer plus multilayer, and usually this is mostly followed, and this is basically applied for the mesoporous materials like cellulose, okay, and even some LDH, layer level hydroxide. Okay, so this is the pic for the type 4 isotherm, and this is my pressure of saturation. Now in type 5, this is not applicable to the BET, and this is the pic. Okay, and this is the template for the BET plots basically. Okay, so volume adsorbed versus the partial pressure, and the pic nature should be like this. Okay, should be after certain time it should be at constant. You can see here. And this is the type of porosity. So we have porous crystalline structures, zeolites, metal organic frameworks. Okay, ordered stacking of small particles generates an interparticles porosity. We have oxides, we have activated carbons, and characterization of porosity. We have Physisorption, we already discussed that. We have surface area. Okay, so the surface area, as I told you earlier, we know a word called total surface area, which is specific for the external surface, while the BET surface area is calculated with whole the surface, such as surface of pores, external surface of material, and calculated by the adsorption of nitrogen gas on the surface of material. And we already saw these terminologies. So, and this is the typical examples of the microporous materials. We have zeolite, activated carbons, metal organic framework, and in mesopores we have mesoporous silica, activated carbons, and macropores we have sintered materials and ceramics. Okay, so in this video we'll be putting all our focus on the theory part. In our second video we'll be talking more about the plotting and how to apply the the plotting, making the plots, and how to analyze the plots and the results of the BET analysis for the research part, or how to write that in the research papers. Okay, thanks for